The four answers were, some of us got them. Well, we know one is one anyway, over here. The other one, minus one, is going to be another one. So 1 minus 1, I is 1, and minus I is the other one.
Why is I 1?
Oh, well, you could do it. You could just sub it in, yeah. What's I to the power of 4? Yeah, okay, yeah, and then...
But negative I, though, to the power of 4.
we can do it.
I squared is negative 1 and I squared. I squared is negative 1 times negative 1 is...
Okay, yep. All right, sweet. Do notice how nicely spaced they're all out. They're all at 90-degree angles to each other. In one full turn of a circle, they're there.
It's going so good.
It was going really well. I missed it.
Look, the tall hop is so good.
I missed it by an absolute mile. In one full turn of the circle, all four are there in one full turn. So I'm going to come back now. I'm not going to do that one yet. I'm just going to go, what's the answer to this?
1 I.
There is no answer.
No, it's 1 I and negative 1.
No, it would not be
negative 1.
Because
No.
I cubed, it doesn't have its complex conjugate.
No. It would.
There's only two solutions, that doesn't exist.
It's 3 solutions. There has to be 3 solutions. We know there's 3 solutions.
1 I and negative I.
Yeah, there has to be
1 and...
I and negative I, just not negative. Yeah, you're right.
No, it's like a mix.
What's I cubed?
Oh, yeah, of course.
I cubed is negative 1.
Negative 1.
Oh, then it's not an answer. Then it's not an answer.
1
Negative
I
I.
and I.
Okay, these are the 4 answers for z to the 4. What's z squared?
1 and negative 1.
1 and negative 1. So if we drew that one out, that one sits here and here. Okay, the 4 of them sit there, there, and there. 4 different, each equally spaced apart.
It'll be a mix.
Hint.
0.
What's one answer we definitely know?
1.
All right. So if I was drawing the roots, 1 is 1. What are the other 2? And
They're in the
I and negative I.
Tease is on the right track and Bo is on the right track. Yes, they have to be complex conjugates of each other. We know that. You may start to think about what angles they would make with each other. Because you know if they have to multiply by itself 3 times and finish at 1, don't they?
Yeah.
Wouldn't the angle have to be perfectly split 3 times? 2 pi over 3, yes. They'd have to be 2 pi over 3 apart, wouldn't they? If you were adding the arguments, so when you multiplied 3 times, it would be at 1 when you multiplied it. So, yeah, I know this is, so what I'm saying is, this one's here, because if you multiply 1 3 times, you get 1. That's obvious. The next one is here, and if we start talking about polar form, if this angle is 2 pi over 3, if you multiplied it by itself 3 times, we don't know the modulus yet, we'll get to that, but if we multiplied this by itself 3 times, once more we'll get here, and the final time we'll get back there. Do we see that? Another 2 pi over 3 and another, because we know De Mor's theorem that you add the argument 3 times, so that will lead us back to 1. Very good. So we know that 1 sits here, 1 sits here. Now what's the values of these 2?
2 pi over 3, 4 pi over 3.
So we know all these angles are 2 pi over 3, yes. We know all these angles are 2 pi over 3. What's this complex number? You can use cis, yeah. I do want my final answer in Cartesian form, but because these are in Cartesian form, the answer to this is 1i minus 1 minus i, which is easy in Cartesian form. We didn't put them in cis. What's these in Cartesian form?
Negative 1 over 2 and root 3 over 2. Or no?
This one is, okay, how would we do it? How would we get it?
Cis 2 pi.
You could look at your... So this is pi over 3. This angle here is pi over 3, if that helps.
Yeah, so we know the angle.
Yeah. So what's this one then? Cis. Pi over 3. Yeah. Positive pi, or cis 2 pi over 3?
And then it's just
Yeah.
Cis 2 pi over 3. And this one would be cis 4 pi over 3, or, yes, we like negative 2 pi over 3 with complex numbers. We'd like to go back this way. So it gives us the same answer. So what's this then in Cartesian form? Cosine 2 pi over 3 is?
root 3 over 2. 1 over 2. Negative root 3.
Negative root 3 over 2.
Cosine.
Yeah, number 2.
Negative 1/2.
Negative 1/2, thank you.
Right.
Negative 1/2
I root 3 over
plus root 3 over 2i.
Yeah.
And this one then would be negative 1/2. You can just see where it is. See, minus root 3 over 2i. All right. They are, of course, complex conjugates. They should be. Yes, because if they occur once, the conjugate must occur if it's a complex number. Do we believe that this cubed is going to be 1?
Let's do it. Let's
Yes, I do. I believe you.
Richmond believes and Tees believes, but I don't know. I got some skeptics around.
Not a single chance.
2 negatives just cancel out.
Okay, I'm going to square it first. Well, I don't know. We'll see. So negative a half times a half is positive a quarter. This times this is negative root 3 over 4, yeah? I, twice. Minus root 3 over 4 again, I.
Minus 2 root 3.
And then this one is going to be positive, but then negative with the I squared. Negative 3 over 4, which gives negative 1/2. These two together, a quarter minus 3/4. Yes?
And then
Negative 2 over 4, which is root 3.
Under 2.
Yes, okay, and now that's it squared, so now you have to multiply it by itself again, which is a negative 1/2 plus root 3 over 2, and we can see, it's like when you're rationalizing.
You get 1 over 4 plus 3 over 4.
Yes, because the middle two are going to cancel and you get 1 over 4. 1 over
Let's do it. Wait, actually, do we get 1 over 4?
These two multiplied do give a quarter. These two, they're going to get opposite signs here in the middle. Minus 3 over 4i plus root 3 over 4i. And then these two multiply is going to give plus 3 over 4. These two cancel, and a quarter plus 3/4 is 1. Happy face.
Well, I don't believe about that minus 1. What about negative 1/2 minus 3?
I know. What I want you to find,
It's the absolute value of that. Absolute value of
He's
1.
joking. What?
okay, all right.
What's the absolute value of 1?
Stop. Okay. All right. So this isn't planned, but could you do? I don't want you to do this one actually, because I forget what the answer to Z5 is.
Oh my day.
Oh, not Z5. Well, there's the. How many will it have?
5.
How many pairs of complex conjugates will it have?
2.
All right. Find them.
Jesus Christ.
1.
Wait, you have to find Jesus. 1. Well, that's the only real one. So there's 2.
And then 2 pairs.
So how do I divide that?